Now we are starting on the top of page 4 in section 6.1. And at the top of page 4 it says steps for finding the value of a normal random variable with a TI 8384 calculator. So we're going to go ahead and give that a star. First thing you need to do is draw your normal curve and shade the desired area. And then you're going to go to second vars and find, for me it was number 3, inverse norm. And then inverse norm, it's going to be typed in the area to the left, mu and sigma. And if you have a newer style calculator, you can actually select left, right, or middle. So from here, we're going to go back up to the examples that we skipped over. And so we're going to go back up to page 3. So go back to page 3. We're going to cross off some stuff. So sometimes it says sometimes we need to find the value of the normal random variable that corresponds with a certain proportion, probability, or percentile. So we're going to go ahead and cross out these steps and not actually use the table and save ourselves some time and just use the calculator. So in order to do this, we're given that z is a standard normal random variable. Find the z for each situation. So the first one, part A, says the area to the left of z is 0.975. Now really quick, remember that the area underneath a any normal curve, and this one's a standard normal curve, has area 1 underneath the curve. And also with the standard normal random variable, the mean in the middle is just 0. So if I know that the area shaded to the left of a z value is 0.975, that means that z would have to be somewhere over here. And I'm going to go label that z. And I'm going to shade this to the left. And this whole entire area that we have here is equal to 0.9750. So we need to go backwards now and find that z value down here. And in order to do this, we are going to type in on our calculator inverse norm. It's the area to the left, which for us is 0.9750. The mean, which is 0, the standard deviation, which is 1, and then close your parentheses. When you do this, we're going to go ahead and round our z scores or z values to 2 decimal places, and we get z is equal to 1.96. And with our z value, I want you guys to notice that it is to the right of 0, which means we should have a positive z-score, and it is. So we're going to go ahead and look at B. This time it says the area to the right. The other one was the area to the left, so you can kind of see both of those. Of z, and remember z is a standard normal random variable, so go ahead and put 0 in the middle. That's our mean. And this time it says that the area to the right of z is 0.143. So it's a small area, and we're shading to the right. And I'm going to go ahead and say this little area here, right of z, is equal to 0.1314. Again, remember that mean cuts that curve, the normal curve, in half, where the area to the left of 0 is 0.5 and the area to the right of 0 is 0.5. From here, we're going to use inverse norm. And then it asks for the area to the left. So to find the area to the left that we have over here, we're going to have to do 1 minus 0.1314, which works out to being 0.8686. And so we're going to put in 0.8686, comma the mean, comma the standard deviation. Again, the mean is 0, the standard deviation is 1. And we are rounding our z values to 2 decimal places, so we get z is equal to 1.12. And again, your z value is to the right of 0, which means it should be a positive value. So right underneath this, we have a critical value. So we're going to go ahead and star. And the critical value says, for a standard normal distribution, a critical value is a z-score on the borderline separating those z-scores that are significantly low and significantly high. So again, here we go. We see the significantly low and significantly high that we've been seeing over the past few chapters. It does say a standard normal distribution. So a standard normal, again, put the mean of 0 in the middle. And it says that the notation for this, expressed as z alpha, denotes the z-score with an area of alpha to its right. So if you had a value, we'll just put a line in here and call this z with a little alpha. And alpha looks almost like a little fish. And the area shaded to the right is going to be the amount of alpha. So the first example that we have down here, you will see that it says find the value of z alpha, which is 0.025. And since it's a z here, we're going to go ahead and put the mean of 0 in the middle on our standard normal curve. And our alpha value is equal to 0.025. And the area to the right is really tiny. It's a small value. It's 0.025, which means our z value needs to be somewhere over here on the right of 0. And we're shading to the right. And this is equal to 0.025, that area to the right. So we're going to go ahead and to find our z value, and z sub alpha, or z 0.025, we're going to use inverse norm, parenthesis, it asks for the area to the right. Again, if you have the area to the left of 0.025 to find the area to the right, we're going to go ahead and do 1 minus that, which is going to be 1 minus 0.025, which is equal to 0.975. So if you have an older style calculator, you're going to put in your area to the left, which is going to be the 0.975, comma the mean, which is 0, and the standard deviation, which is 1. If you have a newer style calculator, you can mess around with it and do the area to the left or do the area to the right. So try that on your own, depending on the style of calculator that you have. When you work this out and you plug this into your calculator, you get z is equal to 1.96. So this is your z sub